Hello, good afternoon, and thank you very much for this opportunity to present the project that we've been all working hard together for the last few years. So I'm going to talk about the SMARTsurg project, so this is the project that was conceived to develop smart wearable teleoperation technologies with particular emphasis on safety and enhanced vision. It has been funded by European Commission Horizon 2020 and with 10 partners from all over Europe. So our mission and the conception of the project was to improve minimally invasive surgeries and to consider this approach in open incision surgeries where minimally invasive approach has not been developed. The project has been developed in collaboration with surgeons from 3 different surgical specialists, from urology, orthopedic surgery, and cardiac surgery. Here you can see the main components of the proposed system. And in the middle here, so here down on the right, you can see comparison at the start of the project with the Vinci system. At the start of the project, we collected a summary of requirements analysis in these 3 surgical specialists from about 40 surgeons, and they can be classified in these 3 categories. So one was in forces used in surgery and haptic feedback, in safety and visualization, and dexterity and telecontrol. So our achievements can be attributed to safety improvements through, on one side, augmented reality toolkit and intraoperative 3D reconstruction, and SMARTsurg augmented reality graphic user interface with a number of different interactive functions, including active dynamic constraints, which were developed to prevent motion of the instrument in close vicinity of blood vessels. On the other hand, we have extended dexterity. So we developed in-house this wearable master, and we developed a new type of 3 surgical forceps with 6 degrees of freedom that was tested while in the lab and on ex vivo samples. We also tested the dexterity, extending dexterity in virtual reality that included both arm and hand dexterity. This was with Mr. Kuparis in North Bristol Trust. And we developed the virtual reality system in Unity. So here it was much easier to test our concept on in a number of different scenarios. Our wearable master was also developed using machine learning for cardiac surgery. So with Professor Aschione, we ran a number of experiments on ex vivo person heart experiments to map the motion of the surgeon's hand with the Castro-Viejo instruments that is typically used in open incision cardiac surgery. I finally have to mention also our pioneering attempts in using machine learning to estimate grasping forces using Da Vinci Grasper. So thank you very much for your attention. And now finally, I would like to thank in the name of the whole SMARTsurg team in UK, Italy, Greece, and France and Cyprus for this fantastic achievement and award. So now the movie.